Introduction to Multivariate Analysis. Hello, everyone. Welcome to today's lecture on Introduction to Multivariate Analysis. Multivariate analysis, in short for MVA, is a set of statistical techniques used for analyzing data that arises from more than one variable. So it is essential for understanding complex phenomena where multiple variables interact. So in fields like finance, marketing, medicine, and social sciences, uh, this multivariate analysis helps in extracting meaningful insights from large data sets and making it a crucial tool for researchers and analysts. Now, let's move on to types of multivariate data. So multivariate data can come in different forms. First of all, we have multivariate continuous data, which includes measurements on a continuous scale, such as height, weight, and temperature. And next is multivariate categorical data, where the data consists of categories like gender, brand preferences, or yes, no responses. And lastly, we have mixed data. What do we mean by mixed data? Mixed data is a combination of both continuous and categorical data. So understanding these types helps in choosing the right analysis techniques. Now let's look at code example. This code example is in Python. For those of you who are not familiar with Python or Pandas, please refer to Python and Pandas lecture. So in this example, we are using Pandas library to create three types of multivariate data we just talked about. So if we look at the first one, we're creating a data frame for continuous data, so which includes height, weight, temperature, and each of these variables is measured on a continuous scale. You can see how height 5.1, 5.9, 6.0, and temperature it's 98.6. Next, we are creating a data frame for categorical data, where we have variables like gender, brand preferences. And to remind you, these are categorical variables because they represent discrete categories. And last, we have data frame for mixed data. It combines both continuous and categorical variables. So you can think of this data frame as a union of the continuous data and categorical data we showed you. And if you actually run this code, you will see how the data is structured in each case. I highly encourage everyone to run this code on your local machine. Now let's move on to objectives of multivariate analysis. So the objectives of multivariate analysis are diverse. One major goal is data reduction and simplification. What do you mean by data reduction and simplification? We mean that we are reducing the number of variables while retaining essential information. Another objective is data classification. It is grouping observations into categories based on their characteristics. We can also use multivariate analysis for hypothesis testing in order to understand the relationships among variables. Prediction is another key objective. prediction allows us to predict the values of one or more variables based on others. And finally, multivariate analysis helps in understanding relationships, so uncovering the underlying connections among multiple variables. Now let's look at principal component analysis, which is also called as PCA. Uh, PCA is a technique used to reduce the dimensionality of data while retaining most of the variation. So if you look at the previous slide, this corresponds to the first objective, which is data reduction and simplification. So this method involves transforming the original variables into new uncorrelated variables. And these new uncorrelated variables are called principal components. And these components are ordered by the amount of variances they explain. Why? What are they useful for? So PCA is particularly useful when dealing with large data sets with many variables, as it simplifies the data structure without significant loss of information. Now let's look at a code example. So in this example, we are using the uh, PCA function from the scikit-learn library to perform principal component analysis. So we can do that by importing the necessary library from scikit-learn and NumPy, and we are creating example data set with two variables in NumPy array, and we can see that each row in our data set represents an observation. And then once we create data, we want to initialize the PCA class. So we're specifying that we want to reduce our data to two principal components. And to do that, we would want to pass parameter called n components, and we're setting that to 2. And then we then fit the PCA model to our data and transform it by calling fit transform method. And this results in the principal components. So these new components are uncorrelated and ordered by the amount of variance they explain. And then finally, we are printing the principal components to see the transform data. So this reduction in dimensionality helps in simplifying our data set while retaining most of the important information. Now we're moving on to factor analysis. Factor analysis aims to identify underlying factors that explain the patterns of correlations within a set of observed variables. So the method models the observed variables as linear combinations of potential factors plus error terms. And this technique is useful for understanding the underlying structure of data, such as identifying latent variables that influence observable variables. If we are to do factor analysis in Python, here is a code example. We want to import factor analysis function from scikit-learn library. And then we will first create an example data set with 3 variables and multiple observation. So once we have data initialized, we can initialize the factor analysis class. And then similar to principal component analysis we saw, we can specify that we want to reduce our data to 2 factors. So we will pass n components parameter and set that value to 2. And by fitting the factor analysis model to our data and transforming it, we are extracting the underlying factors that explain the patterns of correlations in the observed variables. And then once we have factors, we can print the factors to see how the data has been transformed. I highly encourage everyone to do this on your local machine. And as we said before, these factors represent the latent variables that influence our observed variables, helping us understand the underlying structure of our data. Now let's take a look at cluster analysis. Cluster analysis is used to group a set of objects in such a way that objects in the same group or cluster are more similar to each other than to those in other groups. There are various methods for clustering, including k-means and hierarchical clustering. And this technique is widely used in market research for customer segmentation, where we group customers based on their behaviors and preferences, and in other fields for identifying natural grouping in data. So if we look at code example, in order to do cluster analysis, you import a k-means function from scikit-learn library. And you can start by creating an example data set that contains 2 variables and multiple observations. And next, we can initialize the k-means class, and we can specify the number of clusters that we want to create. And in this example, we're going to set number of clusters to be 2 by passing n clusters to be 2. And we can fit the k-means model to our data here. And what happens is that this algorithm assigns each observation to one of the 2 clusters. And the labels array shows the cluster assignments for each observation. Finally, we can use matplotlib to visualize the clusters, and to make it easy to view, we can have each point to have a different color according to its cluster assignment. This way, it allows us to see the groupings of similar observations. And this clustering technique is useful for identifying natural groupings in data, such as customer segments in market research. Now, moving on to discriminant analysis. Discriminant analysis is used to classify observations into predefined classes, and the method involves constructing a discriminant function based on linear combinations of predictor and variables that best separate the groups. And this technique is commonly used in predictive modeling, such as determining which category a new observation belongs to based on its characteristics. So if we take a look at a code example, to do discriminant analysis, we can import linear discriminant analysis function from the scikit-learn library. And then we can create an example data set that has two predictor variables. Here, it's an X here, and then one target variable, Y. And the target variable consists of two classes represented by 0 and 1. And then we can then initialize the linear discriminant analysis class and fit the model to our data by passing X and Y, X being predictor variable and Y being target variable. And then we can use the trained model to predict the class labels for the observations in our data set. And then once we have predictions, we can print the predictions to see the class assignments made by the model. And this, I highly encourage everyone to do this locally and see what prediction value you get. Remember that discriminant analysis is useful for classification problems where we want to assign new observations to predefined classes based on their characteristics. Now we're moving on to multivariate regression analysis. Multivariate regression analysis extends the concept of linear regression to predict multiple dependent variables using multiple independent variables. So this method allows us to forecast or predict outcomes in complex systems where multiple factors influence multiple responses. It is widely used in fields like economics for forecasting economic indicators and in biology for predicting multiple biological outcomes based on genetic and environmental factors. If we take a look at the example, you can import the linear regression function from the scikit-learn library to perform multivariate regression analysis. So to do that, we are just going to create an example data set with multiple independent variables and multiple dependent variables. And then once we have X and Y, we can initialize the linear regression class and fit the model to our data. And the model learns the relationships between the independent and dependent variables. We then use the trained model to predict the values of dependent variables based on the independent variables. So we are passing X, which is our dependent variables, to predict method, and this will return our predictions of independent variables. So this prediction is the forecasted values. Again, remember that multivariate regression is useful for predicting multiple outcomes in complex systems where multiple factors influence multiple responses. Now, let's talk about applications of multivariate analysis. Multivariate analysis is really popular and it has numerous applications. So in finance, it is used for portfolio management and risk assessment. In marketing, multivariate analysis helps in customer segmentation, product positioning, and market basket analysis. In medicine, it is used for diagnostic tests, assessing treatment effectiveness, and conducting uh, epidemiological studies. In social sciences, uh, multivariate analysis assists in survey analysis, demographic studies, and understanding behavioral patterns. Software for multivariate analysis. There are several software options available for performing multivariate analysis. As an example, we've already seen Python libraries like NumPy, scikit-learn. So libraries in Python, as also SciPy, offers robust tools for performing a wide range of multivariate analysis, but uh, Python is not the only software. We have SPSS, SAS, R. So SPSS is known for its user-friendly interface and comprehensive features, thus making it popular among researchers. SAS, also known as SAS, also offers advanced analytics capabilities, and it is suitable for complex analysis. And we have R. R is unlike the above choices, is an open source software, and it has packages for multivariate analysis. And also it is known for flexibility and power. Conclusion. So multivariate analysis is a powerful tool for analyzing complex data sets involving multiple variables. And it provides insights into data reduction, classification, hypothesis testing, prediction, and understanding relationships. This is it for this lecture. Thank you everyone for listening.